294 we have the data available here. Okay, so just see this 294. I think you are able to see this, right? So this is memory access time. What is the memory access time? See here. See here. The speed of the memory unit is the time that elapses between initiation of the operation. Initiation of the operation, processor is requesting, okay, from that time to the completion of that operation. What operation? The data reading operation. Okay, known as memory access time. Okay, now hope you are clear. Okay, everybody understood, I think, right? So the time I'm requesting the data, okay, so initially I'll initiate, I want to read some data. From that time to complete reading of data. I've read complete data, isn't it? So this data I've read completely. So this is said to be the memory access time. Okay, first the difference between or the initiation of the requisition to function complete. What is so reading the complete data? Okay, so this data I have completely read. That is known as memory access time. Okay, then go to the second one, memory cycle time. What is memory cycle time? Memory cycle time means, see here, just see here. So we have a first time go to thousands memory location and read the data. Okay, that is first read data which is available in the memory location 1000, isn't it? So second, after some time, I will request you go to 1020 address and you read one more data. Okay, so this the time is there, no, the consecutive difference between first read to second read. Okay, that is known as memory cycle time. Hope you are clear. Okay, so I will show you the answer in the textbook. Just see to this. Yeah, same page number. Memory cycle time. Memory cycle time means the mean time delay required between initiation of two successive memory operations. Okay, just I'll highlight this. If you want, you can make out then. See here, memory access time. What is memory access time? So just see to this, memory access time, which is the minimum time delay. Okay, so the minimum time delay. Okay, it's not highlighted anyway. So the minimum time delay required between the initiation of two successive memory operations. Okay, so what are those two? Two successive read operations. Okay, so this is what. So first I will go for first read operation. See, first I'll ask you to read the data. Okay, go to thousands memory location and read the data. So after some time, I will ask you go for 1020 address, then read the data. That is said to be a consecutive difference, the difference between the time gap between two consecutive. Okay, that is said to be the memory cycle time. Hope you are clear. Then we have RAM. What is nothing but random access, isn't it? Random access memory. What is random access memory? Random access memory. So random access memory means what? This is a random access memory. So it's an, we have n number of memory locations. We can easily go to locations and access the data. Either you can read the data or you can write the data. Okay, so you don't have any restriction of addresses. You can go to any address, you can access the data. Okay, directly. That is said to be a random access memory. Okay, so using this data, the data available inside the random access memory, you can do the operation, addition operation, multiplication operation, any operation you can do. That means the processor can do by by retrieving the data from which is that memory random access. Okay, so you can go to any address and you can access any data. Then static memories. What is static memories? What is static memory and what is dynamic memory? See, static memory is nothing but what? So we can we will allocate the see 1000 is the address, right? Your locations will be static. I never change. Okay, see here. I'll show you. Wait. So this is what 1000 and 1020 location. So 1030 location, and this is 1050 location. So what's the static memory? So totally how many locations we have? Totally four locations we have. This is location. This is one location. So the memory. So I'm going to allocate the memory. Okay, I'm going to memory. Okay, by the proper addressing. I'll go to particular memory location and I'll access the data. Okay, so I can't change this. addresses or memory. I can't change this. So what is this maximum locations? So 1000, 1020, 1030, 1050. Suppose we have some locations with proper addressing. Okay, I can go to this location, I can take the data. Dynamic means we can extend. Dynamic memories means what? We can extend. So I can extend this memory to little more bigger. I can extend it. But static memory means we can't change the memories. Okay, we can't we can't add more memory. Okay, so whatever existed, so this is what dynamically. Even see here, this is address. No, even this is address, thousands location. I'll go to thousand location, I'll access the data. I can't change even address also. Okay, so I can't do any dynamic thing. Only we can whatever is exist, go to that memory location and access it. That is what static memory is. Okay, so hit rate means what? I will tell you what is hit rate. Hit rate means, see, I'll ask you go and access the data. Okay, I'll ask you to go and access the data. So you'll go to thousands memory location and you will access the data. Yes, you have a data. Yes, I have the data. Yeah, I'll access it. Then it is said to be hit rate. Hit rate means what? I will go and search the data. Okay, so if you're getting the data, whatever the data you are requested, the data is available inside the main memory. So that is said to be a hit rate. Okay, miss penalty means what? So you are searched for a data, but data is not available. Okay, that is said to be miss penalty. But if we want still more input for hit rate and miss penalty, so these two questions I won't include in the assignment question. So these two just remove from the assignment question. Okay, it requires still more paging concept is required. So I don't want to come I don't want to explain that concept right now with since it requires another concept. So these two questions you can remove from the assignment question. Okay, hit rate and miss penalty. Actually hit rate means what? You are going to search some data. If that is available, then successfully you are getting the data, means hit rate positively. Otherwise it is a miss penalty. Okay, so just remove it. Hope you are understood, no? So these two you remove. Then virtual memory organization. What is virtual memory organization? Virtual memory means what? Okay, so let me show you that. Okay, so I'll take one more slide and I'll write it. Yeah, just a second. I'll take one empty slide and I'll write it. What is virtual memory? Yeah, the virtual memory means you take this. This is main memory, right? This is RAM. So suppose I told you this is 2 MB, 2 megabit. Okay, so this is actually the maximum size of the memory. You are getting my words, right? So sometimes you may require more than 2 MB, isn't it? That's why what I will do, I will go to the disk, external storage devices, external storage devices, isn't it? We'll go for external storage device. They're said to be what? Disks, isn't it? They're disks. So I'll go to external storage devices. There's said to be some disk, isn't it? You have drives, no? Drives C, D, E, F, like that. You can make the drives. Okay. So this is RAM, this is main memory, and we have external, some other external storage space available with me. Now what I will do, the data I can store it inside the external memory also. See here, I can store the data even in external memory also. Okay, and from this external memory, I will load the data into main memory. After some time, what I should do, I can load the data to the main memory. Okay, execution. So only for storage purpose, I will store the data inside the external storage devices. But during execution, I'll copy this, I'll move this data into the main memory and I'll execute the data. Okay, so this space is there. No, it's this space. It's something like you never think I have a shortage of memory. Okay, suppose your data in the RAM, it's only 2 MB, but it looks like, see, 10 MB. Even it can hold 10 MB inside the RAM. But existing memory is only 2 MB, but you can extend it to 10 MB. How you can extend it? Okay, what I will do, I will use this external storage devices. Okay, 2 MB I'll store, and remaining 8 MB I can keep it in the outside the memory. Okay, outside the memory means outside the main memory. Okay, so whenever I require, I'll utilize it. Okay, just a second, 1 second. Okay, so what is this? So I can use this virtual memory. Virtually, I can use this external memory as a RAM. Okay, so what I will do, I will take the data, whichever I want to execute, I'll keep it inside the RAM memory. Okay, so after executed, what I will do, I can remove this data from the RAM. Okay, then I can take some other data from the main memory, from the secondary storage device. Okay, so what's the best example is, I'll tell you one simple example. So we have in our college we have two labs. Assume we have two labs. Okay, so only we have some two labs available with us. Okay, with a capacity of, see, okay, only one lab. Okay, only one lab we have with a capacity of 80 students. Assume a lab with only 80 students. So what I'll do, so this is our only one lab existing with me. So what I'll do, so I'll take all 80 students. If I'm not able to explain in one lab, what I will do, I'll take 40 students, I'll keep it in one lab. Okay, remaining 40 students, I will keep it in classroom. Is it okay? Keep it in classroom. Then first I'll explain 40 students. After 40 students completed, then I will take the students from the classroom and I'll make them to sit in the lab. Okay, I can divide, okay, virtually. So the students never come to know that we have a shortage of lab. Okay, 40 students will sit in the classroom, then I'll take the 40 students to the, I'll explain. After the 40 students explanation completes, I take remaining 40 students. Okay, so that's what virtual organization of the memory. Okay, so we have a definition also. I'll show it in the textbook. See here, virtual memory. So what's a virtual memory? Virtual memory means it's another important concept related to memory organization. Page number 3, page number, note down, 294, same page. Okay, so the address generated by the processor directly specify physical locations in the memory. Okay, so but logical, see, virtual memory means you never get the address of physical memory. Okay, how it is possible? See here. So it is said to be what? See what will happen. I'll just show you. This is the address. 1000 is the address. Okay, this is a 1000 address. This is 1010. This is, assume it is 1020. Okay, suppose I want to go for 1020 means, do you have a space in physical memory? This physical memory? No, I don't have a space, right? Because address will be end by 1010 only. Suppose I want to go for 1020 means I should go to this location, external storage device. Even though I have external storage device, the address 1020, I'm not able to fetch this data and I can't execute. What I should do, I'll take this data and I will keep it in some of the location. Okay, so I'll keep the data in some of the memory location. So which location? Okay, I'll take you to this location, see. Okay, this data, 1020 data, I'll keep it inside this. And what's the address of this? This may be 1009. Okay, so you are looking like data available in 1020, but now what is happening? It is not 1020, I copy to 1009. Okay, so converting your virtual address, see, virtual address to the physical address. Okay, now, so we are supposed to copy the data from the virtual memory to the RAM memory, then you can execute. Okay, that is said to be converting your address. What's the address now? This address is known as logical address. Okay, from logical address to physical address. Because I've copied to main memory, right? That is why. Copy to physical memory. That is why physical address. So converting from logical address to physical address, okay, then we will execute the data. Okay, this is known as memory management unit. The memory management unit will take care of this. It will convert the logical address into physical address, and it will copy the data from secondary storage device to main memory or RAM. Then it is possible to execute the code, execute the data. Okay, so that is about our one of the assignment question. So what is that? I think this question. Okay, so latency and bandwidth. So latency and bandwidth is very simple. It's not at all difficult. So I will take you to the direct see. This is in page number 304. Note down page number 304, latency and bandwidth. Latency means what? Latency means delay. Are you agree? Latency is nothing but we have some delay, isn't it? Okay. So I'm trying to change the color. I'm not able to get it. That's all. You class ಮಾಡುವಾಗಲೇ ಬಂದಿದ್ದೀರಾ. Okay. So what will happen? So this is what latency and bandwidth. What is latency and bandwidth? So latency means, what is latency? Delay, right? Delay. So the memory latency is used to refer the amount of time it takes to transfer a word of data to or from the memory. Okay. So I'll show you this one, this slide. See you? Yeah. I'll take it in new page, better. Better if I take new slide, right? Some empty slides is better so that you are able to understand clearly. Suppose we will be having a memory. Okay, this is a memory. Okay, this is the data available A, available in the address 1000. Now I will go to, suppose the time, the latency means what? The time taken, latency. How much delay, how much time it takes. Okay, so I'll go to thousands location and I'll read this data. Okay, this time is known as memory latency. That's all. Okay, the amount taken or the delay to read the data, okay, from the memory location. This is said to be a latency. Hope you are clear. You can ask me one question. Ma'am, memory access time and latency both are same at that time? No, it is not same. Okay, so the reading the data of A is said to be a latency. That's all. Okay, so here requisition from the processor. Memory access means processor will request, right, from requisition time to complete data reading. Okay, memory function completed. Okay, so this time requisition time to memory function completed is said to be memory access cycle. Okay, now sorry, memory access time. But latency is only the time taken to read a data from the memory or write a data to the memory. Okay, that is said to be a latency. Okay, bandwidth. What is bandwidth? What is a bandwidth? See, suppose I'll give you within 1 second, within 1 second, within 1 second, how much data you can read. Within 1 second, how much data you are able to read from the main memory. That is said to be a bandwidth. Okay, so I will show you that particular definition in the textbook. That's better, even you feel more comfortable. See here, bandwidth. Okay, the maximum, see here, why I am not able to get the color? No, I don't know. I couldn't take the color. That's the problem. Okay, so let it be. So just see here, this is the bandwidth. See here, if you're able to see, otherwise I'll read out. In 1 second, see here, in terms of number of bits or number of bytes that can be transferred in 1 second. Okay, number of bits of data or bytes of data transmitted in 1 second per second. That is said to be bandwidth. Note down in the note down somewhere the time taken to the number of bits of data that can be transferred in 1 second. Per second, how many bits of data or bytes of data is transmitted? That is said to be a bandwidth. Okay, so by that, this particular 15K completed. Okay, then go to the 15th B, the single transistor dynamic memory cell. It's very, very simple. See, what I will tell you, we have a RAM, right? So we have a RAM. Assume we have a RAM here, right? Okay, I'll take you to the RAM. Better. Usually I have to take empty slides so you feel more comfortable. Okay, overwriting will be eliminated. So what I will do, I'll return one RAM here. This is a RAM, right? Main memory. This is RAM, right? This is a main memory. You know what? RAM is said to be, so it is a volatile. What will happen? So when, see, I have a data available inside this. I have enough, you see, I have plenty of data. A, B, no, C, D. Lots of data I have inside the RAM. So whenever you have a power supply to this RAM, your data will be available inside this RAM. Okay, so if the power is off, if I'm not going to, okay, at that time what happens, your data will be eliminated, removed. That is why we will call RAM as volatile memory. Okay, so if the power is off, power is on, that means your you're passing the electric charges, then you will be having the data available inside the memory. Otherwise, if you take back the power, okay, at that time what will happen, every data available inside the memory will be removed or erased, isn't it? Erased, isn't it? That is what is said to be a RAM, volatile memory. But what happens, I want to keep the data, for some time. I want to keep the data for some times. Okay. And here what happens, they usually use the transistors. Usually they preferably use the transistors like this here. I'm going to use a transistor. We have a slide actually for transistors. I'll show you that. See, this is how the transistors. See, here you have a data. See, 1 bit. Assume this is 0. If 0 means, so this is said to be 0. This is said to be 1, B dash 1. So then what is your data? Your data is 0. This is how your data bit lines with bit 0 will be stored. Suppose your bit is 1 means, so this B is equal to 1 and B dash will be 0. Okay, this is how the transistor will be used to store the data, either 0 or 1. Okay, so but here what we will do, along with the transistor, what we will do, we are going to use capacitors also. Along with the transistor, even I am going to use capacitors. At that time, what will happen, I can store the data for some time. Okay, I can store the data for longer time, longer duration of time. Okay, so that is why we are going to write a new diagram. I'll write a new diagram. Okay, suppose I'll write a new diagram. Yeah. Okay, I'll write for you. Okay, this diagram I don't have in the slide, so I'll write it here. Okay, so take down this diagram. I don't have in the slide, so I'll write it here. This is the diagram. See here? This is your memory. This is your memory. Okay, so this is how we have a transistors available. Okay, transistor is connected. So this is what transistor. And for this we have a capacitor joint. So what happens, whenever the power will be off, the capacitor will, it has to be, available with, some, picometer of electric charge will be available. Okay, so it will hold your data for more time. Okay, than the RAM memory. Okay, so using this capacitor, it will hold your data for longer duration of time. With the, very picometer, very less power I am going to supply, so that it will keep the data for longer duration of time. And before this, the discharging of the capacitor, how to again charge it. Okay, so that I'm going to keep my data for longer duration of time. So this is what bit line. So bit means what? One bit of data or 0 bit of data. So either 0 I'll put it here, or I'll put it as 1. Okay, so this data will be stored available inside the capacitor. Okay, so this is what, okay, one bit, a 0 or 1, that is one bit. So you can use any number of bits that is said to be one word. This is word line. So word line means what? You can take n number of bits of data and you can store inside the capacitor so that it will be available for longer duration of time, even though power is off. Okay, so that is said to be your one of the assignment question. So that is what I'm supposed to discuss with you. So it's very simple assignment. One or one 5 marks question. So some 5 to 6 lines of explanation is enough. Okay. Okay. So then we have the important concept. We have a very important concept. This is sketch and explain the internal organization of 16M organization. See, 16 mega. So I'm going to give you a memory. Okay. So you have to organize your memory in such a way that the total memory will be 16M. What is 16M? 16 megabits. Okay. So I'll give you that diagram. Okay. See here, 16M. I'll highlight it. Okay, 16M it is. 16 megabits. Okay. 16 MB. Now we have to organize this 16M, one memory, in the manner of 2M into 8. First question. Second question is 1M into 16. Okay, so in that way you have to arrange. So how to arrange that? Okay, so let me show you what is 16M memory. Okay, first I'll take one empty slide. Better. Actually kept with n number of empty slides. I don't know where it has been gone. Okay, so this is what actually one memory. Okay, the very big memory. So it is 16M. This is very big memory. 16M. Okay, now hope you are clear. This is 16M. 16 megabits. Okay, that means what? It can hold 16 into 10 to the power of 6 megabytes of data. This many locations I have in the memory, I can store the data inside the memory, isn't it? Okay, so now come to the point of organization. How to organize? See, it is 16M means 16 mega, so I can store all 16 mega bits of data inside this memory. But they have asked you have to organize this memory in such a manner. In such a manner, they have provided you one question. So organize it in terms of, please note down this, in terms of, first question is, yeah, first question is 2M into 8, isn't it? 2M into 8. 2M into 8. Okay, second question. Second question. I think it is 1M into 16, isn't it? Let me check it out, the question. Yeah, I'll keep this. Let us see. See, 1M into 16. 2M into 8, 1M into 16. Okay. So 2M into 8, 1M into 16. Okay. 1M into 16. 1M into 16. Is both are same? Both are same. 2M into 8 is nothing but what? 2 into 8 is 16. 16M. Even this is also. What is 1 into 16? What is 1 into 16? Again 16M, right? Both are same. But you have to organize in different manner. What is that organization? The organization is you have to choose in such a way that you have to organize 2M into 8 means, see, each location should be of 8 bits. Okay, so 8 bits should be your column. So this is what one word is equal to 8 bits. This is 8 bits. So suppose if you take 8 bits as one word, so how many, how you have to organize your memory? Suppose your word will be 16 bits. So 16 bits means what? So suppose this is 16 bits. How to organize your memory? Hope you are clear. Okay. For that, first we will take you to the first solution, 2M into 8. Okay. So this particular question I have already discussed it in the previous class. Okay. Same thing we will go. I'll take you to the slide. Very simple diagram, this one. Okay. Ma'am, we didn't get anything, ma'am. We are not able to understand anything, isn't it? That's what your question. Okay. So let me write it in one of the slide. Okay. So I'll take you to the slide and I'll go on write it. Okay. See, you have to analyze this particular problem. You have to understand this. Okay. So let me take you to this empty slide. Okay. I'll write it now. So what they have provided, first I'll write it here. It is 2m. Okay, sorry. This is 2m into 8. What is 2m into 8? Again, it is equal to 16m, isn't it? 16m. But they have provided you should use 2m, 2 mega. Okay, and each will be of 8 bits. 8 bits means what? Your memory will be of 8 bits. Your column should be 8 bits. Okay. So how to organize that? For that, what I will do, I'll first take, see, this 2m. How to write this 2m, 2 mega in terms of KB? So first I will take that. So shall I write it as 4096 into 4096? What is 4096 into 4096? Or 4K into 4K? 4K into 4K is what? 4K into 4K, right? So what is 4K into 4K? So 4096 into 4096. What is 4096 into 4096? That is equal to 16 mega. Okay, so what I'll do, this complete 16 mega, I'll divide it into two parts. Okay, first thing is 4K into 4K. 4K into 4K is nothing but 16 mega. First I'll write it as 4K into 4K. I'll divide it. What is 4K into 4K? That is 4000 into 4000, isn't it? So we can't write in terms of 4000. It should be always 4096, 4096. Okay. So this 4096 into 4096, what I will do? I will take the rows. Okay. So row of the memory will be 4096. 4096 rows. Okay. So in three-dimensional array, represent in three-dimensional array. Three-dimensional array means I can write it as 4096 rows. Okay. Into, again, see here, all of you please listen here, 4096 rows into 4096 column. 4096 columns. So totally how many I'll get? 4096 rows. See, 1, 2, 3 goes on till 4096, and even column also 4096, 4096 like this, isn't it? But there is one condition is provided. You can't take 4096 columns. Okay, it should be what? It should be only 8 bits, right? 8 bits means what I should do? I will convert this into again row and column. What is that row and column? This 4096 again I will convert it into, okay, 8 bits. Totally 4096 I'll consider as 4096 divided by 8. Totally how many? 512. See, 512. See here, 4096 divided by 8. How many? What will happen? So 512. So now I will consider as 512 rows, and each row will be consisting of 8 bits. Hope we are clear. 5, 1, 2, okay, rows, and each row is having 8 bits. Okay, like that, 512 rows with 8 bits column. Okay, again that should be repeated for 4096 rows. Okay, it is said to be a simple three-dimensional array. 4096, 512, 512, 8. Hope you are clear. 4096 rows. Okay, in that again 512 rows and 8 columns. Okay, so 8 columns means it could be 8 bits. Okay, That is represented in the diagram as this one, 4096 into 512 into 8 cell array. Okay, we have organized your memory in terms of 4096 into 512 with 8 bits. What is one word? Here one word is equal to only 8 bits. That is fine. Okay, so this particular cell I want to access means I want the addresses, right? So what is the addresses? We want the address. So I can go to these many locations. I can access the data. So with what? With addresses. So how to give the address? Okay, so this is the address. So these many locations address I want. So that address is given by, please see to this. See here, this is row addressing and this is column address. So column I required only 0 to 8. Okay, 0 to 8 is only for column address and row address is for 9 to 20. 0 to 8 for column address and 20 to 9 for row address. This is for row addressing and this is for column addressing. Okay, so row address will be calculated by row address latch. Okay, then that will be decoded so that I can easily go to the particular memory location and access the data. The similar manner, column address will be calculated by column address latch. Okay, so there is one signal is passed known as column address strobe. Column address strobe. This is a signal which will gives you the exact address of the column. Go to this column or go to this row. Here also row address strobe and this is column address. Okay. With this signal, we can go to the particular row, corresponding row and corresponding column. Okay. Ma'am, we are not able to understand, ma'am. There is a small doubt how to write this, row and column addressing with three-dimensional array. Okay. For that, I will do one thing. Okay. I will do one thing. I'll do one thing. I'll take one slide. One two-dimensional array. What is it? Three-dimensional array. Three-dimensional array or two-dimensional array. I'll give you one simple example. Suppose if it is 2 cross 2. How to write 2 cross 2? 2 cross 2. 2 cross 2 means what? Can you tell me what is 2 cross 2? So 0, 1. 0, 1. Okay, this is one cell. 0, 0 means this is one cell. 0, 1 means this is one cell. 1, 0, this is one cell. 1, 1, okay, this is 2 cross 2, isn't it? Are you agree? So I'll write it as 8, 9, 4, 3. Now what is 1, 1? Give me the answer for 1, 1. 1, 1 is what? Answer to my question, what is 1, 1? The data available in the location 1, 1 is what? Audible or not? Exactly, it's 3. Very good. Suppose I have three-dimensional array. Three-dimensional array means I'll tell you. Three-dimensional array means something like this. Okay. See, everybody listen here. 3. 2 cross 2 cross 2. How to write 2 cross 2 cross 2? Something like this. See, I'll write it here. So first two rows means 0, 1. Okay. So this is the location. Within this 0, 1, again two rows. That means again 0, 1. Two columns. So here 0, 1. So first row, again within that we have two rows, 0, 1. Again, this is first row, this is second row, again 0, 1. Okay, again two columns. In both of them is two columns. 0, 1. Sorry, 0, 1 it is. So this we have a cell. This is one cell, this is one cell, this is one more cell, this is one more cell, this is also one more cell, this is also one more cell. Okay, like this. Within one row, we have again two rows. Again here also, within one row, we have again two rows, isn't it? Like that, 4096 rows. This is 0, 1. Only two rows I have written. No, this is 4096 row. Within 4096 row, we have again 512 rows. See, again we have 512 rows. Within this 512 rows, again we have 8 memory locations. That means what? This is 0, 1, 2, 3, like that. How many? 8. 8. Okay, so this is what the locations. Hope you are clear. Okay, suppose I want to access the, okay, I'll write this A, B, C, D, E, F, G, H. Means, what is D? Give me the memory location address for D. D address. No, yaar kodutira first answer. For D, how to access the D? With what memory address? Okay, I will do it for D. Then you can do it for another. See, zeroth row, right? This is 2 divided. So 0, 0, 1, 1. 0, 1, 1 will take you to D, isn't it? Okay. 0, 0th row, within that again 1 row, row number 1, with that column number is 1, 0, 1, 1 will take you to D. Now, what is for F? F ಕೇಳಿ ಲೊಕೇಶನ್ ಇವಾಗ. What is for F? What's for F? Yeah, very good. 1, 0, 1. Right. F ಗೆ 1 row. ಇಲ್ಲ 0 ಇದೆ. 1, 0. Column is 1, 1, 0, 1. 1, 0, 1 will take you to F. Or hope you have understood. That is what 3-dimensional. That's all. It's very simple. Okay. Now, suppose this is very simple. I think you have understood now how to allocate the memory. Okay. So this is for what? This is for very simple. That is what? 2m into 8. Okay, 2m into 8. Suppose in the question they have given 1m into 16. 1m into 16. So what I will do? 1m into 16 is available. So what I will do? I'll make this 16. I want to make this 16. How can I make this 16? So here we have 4096 into 4096. Okay, erase all. I'll erase all. So this is 4096 into 4096, right? This 4096 into 4096. This 4096, I'll divide it by 16. What is 4096 it divided by 16? 256. So I'll make it as 256 into 16. Okay, so then what is row becomes? Row becomes 4096. Again, one more row is 256. Again, that column is 16. That's all. Hope you are clear. Okay, you just change here. Wherever you have 512, change it to 256. And wherever you have 8, you change to 16. That's all. Very simple. That's your second sub question answer. Okay, and address also. What's the address now? Initially it was A 0 to 8. Now change to 0 to 16. Okay, then 17 to 20. 20 to 70, 20 to 17 is the row address, and column address is 0 to 16. That's all. And here also, since it is your data will be 16 bits of 16 locations of data you will get. Okay, 16 bits of data you will get. That is why D0 to D15. Okay, so this is the same diagram. You have to repeatedly write it for your second sub question. That's all. Okay, so I want you to show that question, means I'll show you that question. This question. 1m into 16. Okay, so this is 1m into 16. 2m into 8 and 1m into 16. So just change the same diagram by just making 16. Okay, that's all. Hope you are clear. Okay, so same diagram you have to retrieve one more time, but instead of 8 you have to consider as 16. Okay, so that's all by that. And obviously instead of 512 it becomes 256. Okay, that's all. So this will complete our 16th question. In 17th question we have one more memory organization. This memory organization is nothing but, it is consisting of memory chips. Ma'am, we always give one signal, ma'am, chip select and all, isn't it? Suppose even if you see in this diagram also, we have a chip selection. See here? CS means what? Chip select. Select the chip. Usually we don't have multiple chips, only one chip we have, isn't it? Right now only one chip, so even chip select will be always one it is. But sometimes what happens, we have a large amount of memory, I want it. Okay, at that time what I will do, I will take the memory into n number of chips, integrated chips. Okay, so what I will do, I'll put it as, okay, so I'll just show you here. Yeah, so I will take you your memory. Suppose if your memory is, okay, this is 32 m, so I'll divide it into 16 m. 16 megabytes as one memory location, 16 megabytes as another memory location. 16 m plus 16 m, that becomes 32 m, isn't it? So what I will do, so this is one chip. Okay, again this is one more chip. Okay, so same memory, I divided it into two parts. This is one chip, this is second chip. Okay, so I load the data into first chip. In this chip, I'll load it, my data. After the complete, it is filled, then I'll go to second chip. I'll fill the data to the second chip. Okay, I can integrate it n number of chips so that you can select whichever the chip you want. You can select and you can store the data. Okay, that is why we have used the code chip select. Hope you are clear, isn't it? Suppose I'll be having two chips, means see here, this is one chip, two chips, isn't it? So how many bits I required? 0 or 1. So 0 means I'll go to this, 1 means I'll go to this. 0 means I'll go to this chip, 1 means I'll go to this chip. That is what chip signal. Okay. Suppose I have four chips. Four chips are there. Okay. So 32 means what? How many? 1 becomes 8, right? 8m, one chip, second 8m, this is 1 8m, this is 1 8m. So how many chips we have? 4 chips. How to select the chips now? So this is 0 chip, 1 chip, 2 chip, 3 chip. So how many bits you required to represent 4 chips? How many bits you required? How many bits to represent 3? Number 3? Yeah, 2 bits, right? So obviously. So 2 bits. So 2 bits means what? 0 0, 0 1, 1 0, 1 1, isn't it? So 0 0 means which chip it will take you? Take you to the first chip. Okay. So 0 1 means next chip. That is this chip. 1 0 means this chip. Last 1 1 means this chip. Hope you are clear. So how many bits are required? 2 bits. 2 bits are required to select the chip. Hope you are clear. Everyone is clear? Okay. So here same 4 chips I will return in this diagram. Okay now. So I will take you to this diagram, which is your assignment question number. Okay. See this question first. The last question which I'm supposed to complete in the syllabus. Okay. So 2m into 32. Okay, 2m, 2 mega into 32 means what? Actually 64 MB. 64 megabyte memory you have to organize in such a way that you have to organize it into n number of chips. Okay, each will be 512k into 8. 512k into 8. See, 512k is one chip. Means how many chips I required for it becomes 64m? Can anybody tell me? A small calculation. ಎಷ್ಟು chip ಬೇಕಾಗುತ್ತಾ? 512k into 8 if I use means how many chips I required to make 64m? Simple calculation. No need to break your head. I'll tell you very simple calculation. See here. See, they have given 512, right? That's what, no? 512 into 8. Isn't it? This is one chip. Okay. Assume if you take 4 chip, what will happen? 4 chip means what? 512, same, 8, 512, 8, 512, 8. Just add it. 8 8 8 8 means what? 8 fours are 32. So 32 into, what is 512, 512, 512, 512? It's something like 500, 500 will be 1000. Again 500, 500 will be 1000, right? Isn't it? So this is nothing but, so this will be into 32. So 512 into 512, 1000 into 1000. So that becomes, see, 512 into 512 is to. Okay, we can't write like that. Just a second. 2048. 2048 means what? 2048. Oh, it becomes 2k, la? Just a second. I'll see the question. Wait, 1 second. Yeah. Okay, okay, pa. You are correct. You are correct, pa. Your some student has given answer, no? It becomes 2k, isn't it? That's correct. Suppose if it is 512k, it is. ಈಗ ಹೇಳ್ತೀರಾ 512k, 512k, I missed this k. 512k, 512k. ಈಗ ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ? ಈಗ ಆನ್ಸರ್ ಕೊಡಿ. I missed k there. ಎಷ್ಟಾಗುತ್ತಪ್ಪ? It becomes 2 mega. That's all. 2 mega into 32. Correct? Am I correct? Hmm? Okay, that's all. 2m into 32. That means what? 2m into 32, I will divide it into 4 parts. What is that 4 parts? 4 chips I will select. Okay. The same thing I will represent in the diagram. Let us see how the diagram looks like. Okay. Just see the diagram. Okay. The diagram is this one. You're able to see? See, this is 512. This is first chip. Okay, this is first chip. This is completely first chip. This is second chip. Okay, organize it. Okay, first chip. This is second chip. This is third chip. This is fourth chip. Okay, and how many bits I want? To go to the first bit, second bit, third bit, fourth bit. I want 2 bits, right? So 2 bits. 2 bits I will use it. Okay, and go to this exact locations, memory location, and access the data from this particular locations. See, again, you don't think they are all, again they are chips. They are not chips actually. They are organized it into a group. This is one memory addressing group. This is another second addressing group, like that. Nothing to worry. Okay, so we have 512k into 8. That is nothing but what? So I will go to memory locations. So go to this particular chip and go to this particular chip. This is third chip. This is fourth chip. Okay. So that is what? So 512. This is completely, one will give you 512k into 8. Into 8 means what? 512k into 8 means 512k rows into 8 bits. Okay. So it will give you totally how many locations? 512k locations, rows, and 8 columns. Here also 512k rows into 8 columns. 512k rows into 8 columns. Not 8 columns. It is nothing but 8 bits. 8 bits means 1 byte. Okay, like that. So I'll go to any memory location and access the data. Okay, so address location I required is, it was totally 21 bits. So out of 21 bits, 19 bits I will use for finding the data, and 2 bits I'll use for identifying the chips, which chip, for which chip I should move. Okay, so 19 bits of address is utilized for go to the exact memory location. Okay, and which memory location, which chip I should go. So that is done by, out of 21, 19, 2 bits is left. No, so this 2 bits, that is 19 and 20. 19 and 20 is used for chip selection, and 0 to 18. 0 to 18 means what? Totally 19 bits. So that is used for addressing. Okay, so this is your one of the assignment question, that is 512k into 8 memory chips. Okay, hope you are clear. And each, see, I can parallelly access the data. go to this particular chip and access the data parallelly. And even from this also you can access data parallelly. Okay, suppose I'll go to this chip and I'll access the data, means your data will be from 0 to 7. Okay, so 1 byte of data I will access 0 to 7. Okay, and here 8 to 15 no bits of data, and 16 to 23, and 24 to 31. So like that I can access totally how many bits of parallelly I can access how many bits of data, totally 34 bits, sorry, 32 bits of data I can access simultaneously. So 32 bits means how many bytes it is? 4 bytes, isn't it? 4 bytes. So 1 byte from first chip, 1 byte from second chip, 1 byte from third bit, 1 byte from fourth bit. That means you can access the data from each and every chip, directly, parallelly you can access. Okay, that means you can read the data so fast. Hope you are clear. Okay, so that will complete our one of the assignment question, that is your 2M into 32 memory using 512K into 8 memory chips. Okay, now. Okay, so by this we have completed all assignment questions. Okay, so now any doubts you have? Okay, so this I will. Any doubts you have? Okay, one question from the student. Can you explain? We have taken 9 to 20, 0 to 8 in the question number 16. See Aditya. Yeah. In question number 16, right? So I think 16 means this one. Okay, see. So, see, 0 to 8 means what? How many bits you have? 0 to 8 means it is around 9. 0, 1, 2, 3, 4, 5, 6. Totally it was 9. Alva Aditya? Yes, Aditya? Yes, Aditya. What is 2 to the power of 9? Aditya, 2 to the power of 9 ಏನಪ್ಪಾ? 512. ಅರ್ಥ ಆಯ್ತಾ ಆದಿತ್ಯ? ಸೊ ನಿಮ್ಗೆ ಅಲ್ಲೇ ಆನ್ಸರ್ ಸಿಕ್ತು ನೋಡು. ಯು ಆರ್ ಗಾಟ್ ಟು ಆನ್ಸರ್ ದೇರ್ ಓನ್ಲಿ. ಸೊ 512. ಸಿ ನಾನು ನಿಮ್ಗೆ ಏನಂತ ಹೇಳಿದ್ದೀನಿ? Okay. See, everybody, it's a very good question from Aditya. Very good, Aditya. Superb. Only those students who have understood, only they can ask the question like this. Aditya, I'll write for you, okay na? I'll write you better. See here. Yeah, I'll use pen. Okay. So this is 4096 into 512 into 8. Isn't it, Aditya? I told you 4096. Again, this will be divided it into n number of rows, 512 rows. Isn't it, Aditya? That's why this 512 rows, this rows is there, no? This row addressing I required, that is given by A0 to 8. That is nothing but 0 to 8 means 9. 9 means 2 to the power of 9. That will gives you 512. Okay, now? So 0 to 8 means 0 to 9, that means 9 bits. So 9 bits. Using 9 bits address, I can take you locations of 0, 1, 2, 3, like that, totally 512 locations.
Ma'am, screen is not visible,
Oh,
ma'am.
sorry, not shared. Sorry, pa. Just a second. Yeah. So I've written not visible. I've written on the slide. So I'll try it one more time, right? Okay, let me write it one more time. I'll write it one more time, better. Now visible, alva. Ivagidella, you're visible. Okay, let me write it now. Yeah, it's visible. Yeah, I'll take you to the empty slide. See here. See, nodi 4096. 4096 cross 512 into 8. Okay, so it is nothing but 4096 rows. Again, in that we have 512 rows, isn't it? 512 rows. So each is of 8 bits. Each is of 8 bits. Okay, so this 512, I'll go to first row, I'll go to second row, like that I'll go to till 511 rows, isn't it? So these address I am getting by the A0 to 9. What is A0 to 9? Sorry, A0 to 8. A0 to 8 means 9, A9. A9 means what? 2 to the power of 9. 2 to the power of 9 means 512. So this, go to this location, go to this location. Okay, so what I am getting, because of the address, 9 bits of data. 9 bits in Rayanappa. So address will be totally, something like the 0, 1, 0, 0, 1, 0, 0, 0, 0. Okay, this is the address. 9 bits. First, this last, the the least significant bit, 0 to till here. Okay, these many bits of data will take you to the 512 locations of your data from the row. Which row? Out of 4096, first row. From this first row, I'll take you this particular 512 locations. Okay, with the address of A0 to 9, A0 to A0 to 8. So that is what given in the diagram, this diagram. Yeah, which diagram? This one. This diagram. Okay, Aditya, clear? Okay. Okay, just a second. I'll doing one more small calculation here. Okay, Aditya. Aditya, you're there? Yes. Idira Aditya? Okay, Aditya. Now, so this is for 512 I told you. Okay, now 0 to 8. Ega 9 to 12. How many bits are there? 9 to 12. Count Madi. Count and give me. 9 to 12. Totally, how many bits will come? 9 to 12. 9, so 9 to 12, 9 to 20. See, 9 to 20 here. This is a diagram. Sorry, 9 to 20. So sorry, 12. 2 to the power of 12 is 2, Aditya. What is 2 to the power of 12? Exactly, 4096. So you got that address? 4096 address is how I am getting 2 to the power of 12 bits will take you 4096 rows. Again, in that 4096 rows, go to first row. In that first row, again you have 212 rows. That 212 rows, sorry, 512 rows is available with the address of 0 to 8. Okay, now? ಈಗ ಅರ್ಥ ಆಯ್ತಾ 4096 rows ke 9 to 20 address bits that bits will give you that location. Again, within that 4096, again we have taken, remember your 3-dimensional array. I've showed you, no? Okay, remember that. Again, I want 512. That 512 is available with 0 to 8. That means 9. That means 2 to the power of 9, that is 512. Okay, that is what addressing. Clear? That 0 to 8 and 9 to 20 clear? Hope everyone is clear. Okay. Okay. Hope see actually, you know what was my plan actually. So I'm supposed to divide this 3 questions today, 2 questions, and 1 question by next day. But what happens Monday? I don't have your class, isn't it? So only I have the class on Thursday. Hope you are clear. So Thursday was very, long gap, isn't it? That's why what I felt, let me complete it by Saturday only. So let us complete the thing. Later, we can go to the revision and all. Okay, that is what I have done today with all 3 questions continuously. Hope you people felt little fast today. Yes? Or okay? So I given page number, everything. Okay, see page number 4. See this memory, I'll give you the page numbers. Ma'am, for online internals, how many questions from question bank? See, we planned, see, what our plan is, what we have discussed, what are the problems we have, the same problems will give, but we will change the values. Full, whatever the value we have, completely will change. Okay, problematic questions. Okay, remaining concepts from the syllabus. That means what? Whatever the syllabus is, we have given the same questions available in uh, this one assignment. Okay, same questions only, a little bit change. Suppose I'll give you one example. Suppose I will take you this particular question, right? So for that is what 2 questions we have. 2m into 8 is 1 question, right? Then 1k into 16, 1 question, right? So we'll change it. The value will change and we'll ask you to write it. Okay, like that we'll modify the questions. Maximum we felt like modify maximum things. So much changes. Other than that, we will make some, additionally we'll add some questions from the syllabus. Okay. Suppose I'll give you one simple example. Which question I could add? So this one. Yeah. See, this question, which is not given in the assignment question, isn't it? Internal organization of memory. First basic question. Not added. See, this question. I can ask you this particular question. Explain the internal organization of memory. This question I may ask. Okay, like this, I could ask the question from the syllabus. Okay. I can add some questions from the syllabus. Suppose if you take some 8 questions, Andra, so maximum 2 questions you may get from assignment, but remaining 6 questions may be out of the assignment. Even if you get from assignment also, if you may get some questions from assignment, but the values will be totally changed. Okay. Okay, I see. I'll give you the page number for today's class. Page number I'll give you. Okay, now take the page number for question number. Ido yadu A 15th A. Take the page number from the textbook. 310. 310 and 310. So I'll take you 310 page number. Sorry, it's not 310. Sorry. Just a second. Don't take down. Yeah. Page number 294. Somebody type me. You'll type Madi so that others will see that. I can't type from my system because I have screen share. No, I'm not able to type. Type ಮಾಡ್ರಪ್ಪ 294. Okay, now again we have some questions available in 294 ಆದ್ಮೇಲೆ 320 ಎಲ್ಲ one line ಆಯ್ತಾ one line ಅಷ್ಟೇ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇರಬೇಕು. ಸೊ ಪೇಜ್ ನಂಬರ್ 304 ಆ ಹಿಟ್ ರೇಟ್ ಮತ್ತೆ ಮಿಸ್ ಪೆನಾಲ್ಟಿ ತೆಗ್ದಾಕಿ. ಡೋಂಟ್ ವಾಂಟ್ ಇಟ್, ರಿಮೂವ್ ಇಟ್, ಅದೆರಡು ರಿಮೂವ್ ಮಾಡಿ. ಓಕೆ, ಸೊ ನಿಮ್ಗೆ ಇಲ್ಲೊಂದು ಒಂದು ಸಿಕ್ಸ್ ಸಬ್ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ. ಇಟ್ ವಿಲ್ ಗಿವ್ ಯು ಟೋಟಲಿ 5 marks. ಸೊ ಟೇಕ್ ಯು ಲೇಟೆನ್ಸಿ ಅಂಡ್ ಬ್ಯಾಂಡ್ ವಿಡ್ತ್ ಇದು ತಗೊಳ್ಳಿ. ಇಲ್ಲಿ ಎರಡು ಕ್ವಶನ್ಸ್ ಇದೆ. ಲೇಟೆನ್ಸಿಗೆ ಇಲ್ಲಿದೆ ವಾಟ್ ಇಸ್ ಲೇಟೆನ್ಸಿ ಅಂಡ್ ಬ್ಯಾಂಡ್ ವಿಡ್ತ್ ಆಲ್ಸೋ ಯು ಹ್ಯಾವ್. ಲೇಟೆನ್ಸಿ ಅಂದ್ರೆ ಡಿಲೇ. ಓಕೆ, ಟೈಮ್ ಟೇಕನ್ ಟು ರೀಡ್ ದ ಡೇಟಾ ಆರ್ ರೈಟ್ ದ ಡೇಟಾ. within 1 second how much? ಹೌದು, ನಾನು ಆಕ್ಚುಲಿ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಈಗ ಮತ್ತೆ ನೀನ್ ಚೇಂಜಸ್ ಹೇಳಿದ್ರೆ ಮತ್ತೆ ಮಾಡ್ಕೋಬೇಕು. ಸರ್ ಹತ್ರ ಇದೆ, ಸರ್ವೆಂಟ್ ಸರ್ ಹತ್ರ ಚೇಂಜ್ ಮಾಡಿಸಿ
ಮೇಲ್ ಕಾಪಿ ನಾನು ಕಳಿಸ್ತೀಯ.
ಕಳಿಸಿ ಮುಂಚೆ ಕ್ಲಾಸ್ ಮುಗಿಸ್ಬಿಡ್ತೀನಿ. ನಾನು ಅರ್ಜೆಂಟಾಗಿ ಸಿಲೆಬಸ್ ಮುಗಿಸ್ತೇನೆ. ಮುಗಿದ ತಕ್ಷಣ ನಾನು ನಿನ್ನ ಹತ್ರನೇ ಬರ್ತೀನಿ.
ಇಲ್ಲ, ನೀನ್ ಮೇಲ್ ಓಪನ್ ಮಾಡಿಲ್ಲ ಬಿಡು, ನಾನು ನೋಡ್ಕೊತೀನಿ.
ಅಯ್ಯೋ ಬೇಡ ಕಣೆ. Okay, now. Okay, so go to page number 304. Somebody type here 304. 304. So 304 ಮತ್ತೆ 290. I didn't remember. Okay, those two page numbers for your first question. ಇದು 15th A ಗೆ. Okay, miss penalty hit rate, remove it. Then go to 15. See, why I'm not including hit rate and miss penalty means we have page replacement. In page replacement we have this concept. So simply hit rate and miss penalty giving one line definition, it's not a fair, isn't it? So I'll just remove it. Anyway, this is 5 marks question. No, enough. Then we'll go to a single transistor dynamic memory cell. Okay, so I'm going to charge it so that I can keep the data in the capacitor. Okay, so that is available in page number. Yeah, this is a very small diagram. You can go to the page number. Sorry. Yeah, page number 299. 299. Okay, I'll show you if you want. Just define it and small explanation is required. 299, right? Sorry, 299. Okay, this one, this diagram pa. Clear? Somebody type P, illi 299 anta, page number 299 for 15th B. Aita, idu with the small explanation you have to explain, that's all. Okay, so yeah, 15B. Next one now, which question? 16th alva. See, 16th, one question, 2m into 8, you have the answer. Okay, I'll give you the page number. Page number is 300. This one. Ida 300, page number 300. You have to explain this. Okay. $300. Okay, now. So the this question. 16th first sub question. Second sub question you have to change. Here only you have to change it into 4. Instead of 512, you change to 256. 256 into 16. Okay, if possible, if possible, I will draw you the diagram and I will send you. Okay, now, if any changes other than whatever I said, still I felt some changes is there, 100% I will give you the changes. Okay, here 256 into 16. Here it is D0 to D15. ಇದು change ಆಗಬೇಕಿದು. Address we have to calculate. What could be the address? Y12 256 means a small change in the address. I'll calculate and I'll tell you. Okay, this address was I have to calculate and I'll tell you. I will calculate and I'll give you this information. Okay. Anyway, you write it one new answer. One more answer I will give you diagram. Okay. Anyway, page number is 300. Type ಮಾಡಿದ್ರಾ page number 300 ಅಂತ. Okay. So ಅದು ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ಬಂದು ಅಷ್ಟೇ 16th ಅಷ್ಟೇ. 17th A. 17th A ಗೆ answer was directly in the textbook. Okay, I'll tell you the page number. 17th page number 306. Type ಮಾಡಿ page number 306. Okay, I will take you to the page number 306. This is page number 306. This diagram. I have to write this diagram and you have to explain. That's all. Okay. Adu istu memory. In the memory, we have this many questions. Okay. So 15, I think 17B ಬಂದು ಇದು interface ಇದು. 8-bit serial interface unit. Okay, serial interface unit is your, second module. Is it second module it is? Okay, so this, if you want interrupt, exception, DMA is there, no, that module will be 8-bit serial bus will come. Sorry, serial bus interface, serial interface unit will come. Okay, so memory, from memory only you have this many questions. Okay. PCI bus okay. Okay, now from memory only this many questions. So remaining question, can you tell why we are taking addresses in bits too? Yeah, very good. Okay, I'll explain you that. Just a second. I'll take you the slide. I'll take one empty slide. It's a very good question. Yeah, I'll take you to the empty slide. I'll take and I'll explain. Okay, first I will read her question clearly. 1 second. Bitrate is not there. Okay, now Ananya, for your question, iterate is not there. This penalty not required because that's still I want to complete so many concepts. So not right now I don't want to include that question in the assignment. Can you tell why we are taking address in bits to access bytes? Like for 512 bytes, we are taking 9 bits address. Okay. I'll take one empty slide and I'll explain. Okay. Okay. Yeah. Sipa, ಯಾರದು the question ಕೇಳಿದ್ದು? I didn't remember her name. Who is that call? Okay, it's okay, pa, whoever it is. Okay, see, suppose suppose I want to store the data. This is one small memory. Okay, now one small memory. Okay, pa, I want to store the data. Okay, I'll take little bit smaller. This is a memory location. I want to store the data only with a length of only 1 bit. ಈಗ ಒಂದೇ 1 bit ಇರುತ್ತೆ. Only 1 bit. I want to store it inside the memory. Okay, inside this memory, I can store either 0 or I can store 1. So how many addresses I record for this? Guest address ಬೇಕಾಗುತ್ತೆ. So I will go to this memory location. Inside this memory location, I can store either 0 or 1. ಇಲ್ಲ 0 ಇರ್ಬೋದು ಇಲ್ಲ 1 ಇರ್ಬೋದು. Assume it is 0 I have stored inside this memory. So if this is the data, that means only 0 I am able to store inside this, or 1, anything. So how many addresses I required? Only one address. Alpapa, only one address. So that I will denote it by, see here, 2 to the power of 0. 2 to the power of 0 is equal to what? 1. So only one memory location is required. Okay, na? Okay, na? Okay. Still you have doubt. Suppose I want to store the data 1. Inside this one memory location, only one memory. I don't have any other data. So I'll erase all. Only one location. Inside this location, I can store only one bit. What's that one bit? One bit may be either 0 or it could be 1. Okay, so how many locations I have? Only one location. So how many locations address I require? 2 to the power of 0. 2 to the power of 0 means 1, right? Only one location. That is why I will always use 0, means only one bit. One bit address. One bit address I will represent it in terms of 2 to the power of 0. 2 to the power of 0 is equal to 1. 2 to the power of 0 is equal to 1 means one location. That's all. Suppose my memory will able to hold not only one memory location of data, it can hold around 4 locations. 1, 2, 3, 4. Now can you tell me what's your address could be? What's the address of this? 0th location. What's the address of this? First location. What's the address of this? Second location. What's the address of this? Third location. Can you give me how many bits I wanted? Just bits ಬೇಕು to represent locations. Can you tell me how many bits I required? Hey, answer ಮಾಡ್ರಪ್ಪ. How many bits? 0, 0, 0, 1, 1, 0, 1, 1. How many bits I required? Yeah, not 4 bits, Aditya. 2 bits. See, 2 bits. Only 2 bits. With the 2 bits, I can represent 0th location. 0th location means 0, 0. With the 2 bits, I can represent 1. What is that? 0, 1. With the 2 bits, I can represent 2. What is that? 2, 1, 0. With the representation of bits, 2 bits, I can represent 3. So 3. So I'll be having 4 locations. So how to write that? 2 to the power of 2 bits. If I use 2 to the power of 2 bits, so how many locations I can make you? 4 locations. ಗೊತ್ತಾಗ್ತಿದ್ಯಾ? Okay. ಇನ್ನೂ ಒಂದು ಬರೀತೀನಿ. I'll write one more. Suppose 6 locations. My memory can hold totally 6 locations, isn't it? 8 locations. 8 locations means what? Totally something like this. 1, 2, 3, 4, 5, 6, 7, 8. Now tell me how many bits could be. Yeah, 3 bits it could be. Exactly, 3 bits. That means what? First location is 0, 0, 0. Second location is 0, 0, 1. Next to 0, 1, 0. Next to 0, 1, 1. Next to 1, 0, 0. Next to 1, 0, 1. Next to 1, 1, 0. Next 1, 1, 1. With the 3 bits, how can I represent in terms of 2? Can you type for me? 2 to the power of ಎಷ್ಟು? In terms of 2 ಬರೀಬೇಕು ನೀವು. 2 to the power of 0 ಆಯ್ತು. 2 to the power of 2, 4 locations. For 8 locations, how many? In terms of 2. 2 to the power of what will make you 8? Yeah, 2 to the power of 3. So 2 to the power of 3, that means 3 bits. Your address is 3 bits means 2 to the power of 3 will give you 8 locations. Now come to the question. Your friend has asked, no, that question. Suppose I want 512. I want 5 locations. Andre, 2 to the power of what? I don't know. Question mark is equal to 512. 512 locations. So now tell me 2 to the power of what is 512? 2 to the power of what is equal to 512? Yeah, 2 to the power of 9 bits, right? So 2 to the power of 9 is equal to 512. That means your address will be what? 000. Starting address will be what? 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 000. 0 9 bits means 0, 0, 0, 0, 0, 0, 0, stop, 4, 5, 6, 7, 8, 9, 0, 0, 0, 0. Next location, 0, 0, 0, 0, all zeros, last will be 1. Like this goes on, continue till 511. Why it is 511? Because 0 to 0, it is starting from 0. That is why 511. 0, 1, 2, 3, 4, 5 goes on till 511. Okay, in binary. That will give you that memory locations. You can represent with in terms of bits. Okay, with the formula 2 to the power. See, 512 bytes ಯಾಕೆ ಗೊತ್ತಾ? ಚಂದ್ರಕಾಂತ ಕ್ವಶನ್ ಕೇಳಿದ್ದು, ಆದಿತ್ಯ ಐ ಥಿಂಕ್. See, bytes means inside this 512, see 512 locations we have. Inside this locations, first location, I'll be using 5 bits of data. 5 bits means 1 byte. That is why they have written there 512 bytes anta. It will hold 512 bytes of data means first location 1 byte, second location 1 byte, second location, third location 1 byte, 8 bits of data. That is why it becomes 512 bytes it is. Okay. 512. Okay. 8 bits it is. 8 bits andre 1 byte. 8 bits ಅಲ್ಲಿ 1 bit, 1 location, 1 bit no, you can divide it into 8 locations. Usually the 8 locations ಅಂತ ಬರಲ್ಲ. ಅದು 1 cell it will take, no, that is why it is 8 bits. Each location you can access the data, that's how. Okay. Yeah, you study once. So if you study, you may get a number of doubts. You ask me that, and even you may solve a number of, it will clear a number of doubts. If you study the textbook, no, it will clear the doubts also. Simultaneously, it may create the doubts also. Both will happen. Memory system is not so easy it is. It's not a theoretical question it is. It's an analysis question, analysis topic it is. We have to analyze each and everything. Okay, so let me check the time. Okay, I will take attendance now. Let us see. And you know what I'll do, if possible Monday or tomorrow or today, I don't know. Okay, if you want, I'll put the mark page numbers, I'll provide it. You can use that. Okay, ma'am, I am asking from which question number it starts and it ends, so we can prepare properly. No, I didn't get your question. ನನ್ಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ನೀವೇನ್ ಕೇಳಿದ್ರಿ ಅಂತ. ವಿಚ್ ಕ್ವಶನ್ ಅಂದ್ರೆ ಕ್ವಶನ್ ಬ್ಯಾಂಕ್ ಕ್ವಶನ್ ನಂಬರಾ? ಓ, ಫ್ರಮ್ ಕ್ವಶನ್ ಬ್ಯಾಂಕಾ? ಓಕೆ. ಕ್ವಶನ್ ಬ್ಯಾಂಕ್ ಅಂದ್ರ ಪ್ರಾಬಬಲಿ ನಾನು ಚೆಕ್ ಮಾಡ್ಬೇಕಾಗತ್ತಾ? ಐ ಹ್ಯಾವ್ ಟು ಚೆಕ್ ಇಟ್ ಔಟ್. ಲೆಟ್ ಮಿ ಚೆಕ್ ಇಟ್ ಔಟ್. ಅರ್ಥಮೆಟಿಕ್ ಅಂತೂ ಕಂಪ್ಲೀಟ್ ಮಾಡ್ಯೂಲ್ ಇರುತ್ತೆ. ಅರ್ಥಮೆಟಿಕ್ ಫುಲ್ ಮಾಡ್ಯೂಲ್ ಇರುತ್ತೆ. ಇದು ಬಂದು ಸೆಕೆಂಡ್ ಮಾಡ್ಯೂಲ್ ಬಂದು DMA ಇಂದ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ DMA ಇಂದ ಇರುತ್ತೆ. ಓಕೆ, DMA ಇರುತ್ತೆ. ಮೆಮೊರಿ ಬಂದು, ಸೊ ಮೆಮೊರಿಯಲ್ಲಿ ನೀವೇನ್ ಮಾಡಿ ನೋಡೋಣ. ಐ ವಿಲ್ ಡಿಸ್ಕಸ್ ವಿತ್ ಒನ್ ಆಫ್, even Chaitra ma'am is there for another section, so we'll discuss together. Okay na? So arithmetic complete module ಓದ್ಕೊಳ್ಳಿ, all complete module arithmetic. And ಇದು DMA, it starts from DMA I think. In memory I will tell you, probably we won't add more questions in the memory. ಇಷ್ಟೇ ಇರುತ್ತೆ, assignment questions ಅಷ್ಟೇ ಇರುತ್ತೆ. Even if it is change also, a small change. Okay, we will tilt no problem questions a little bit, that's all. Okay, so let me tell you that probably from memory though we don't want to add extra concept. Okay, you just send 5 questions so we can play. No Aditya, college has been strictly told nothing should be given to students, and even question paper whatever I'll prepare, that will be available to me. The out of, suppose I'll give them some 12 questions or 8 questions, So suppose 12 questions, I'll give them additional questions. So then in that they will give me some 5 or 8 questions before 15 minutes to the test. Even faculty don't know which question is available in the test. Question paper will be prepared, questions will be prepared by the faculty, but question paper will be prepared not from the faculty. Even I don't know. Not even me. No faculty knows. Okay. Okay, anyway, I'll discuss with ma'am once. What's her idea? Okay, because we have to concentrate on both the sections, right? Okay, let me discuss with ma'am, and any favorable we could do for you people, let us do. Okay. Asta? ಈಗ ಇದು ಕ್ವಶನ್ ಕೇಳಿದ್ರಲ್ಲ ಯಾರಿದು? ಆದಿತ್ಯ. ಕ್ಲಿಯರ್ ಆಯ್ತಾ ಕ್ವಶನ್ಸ್ ಡೌಟ್ಸ್ ಕ್ಲಿಯರ್ ಆಯ್ತಾ? Okay, nothing to worry. Still we have in memory system andre we will take more classes. Whenever the concepts comes, we will take small concepts also we will discuss. Okay. If still you have any doubts, you can ask by that time also. Okay, Asta was absent. Yusuf?
Present, ma'am.
Okay. Abhijit Kumar? Yeah. Abhishek Bonwal? Okay. Abhijit present. Okay, Asta present. Abhijit, 3 number present. 5? 5. Question number 5. Abhishek Mishra. Adish? Okay. Aditya? Okay. Aditya Pratap? Okay. Aditya Raj? Akanksha? Akili Chakravardhan? Okay. Akshat? Okay. Amog? Mog is absent. 13. Okay. 14 present. 15. Okay. 16. 17. 18. 19. 19. 19. No reply. Ankita Niranjan. Ankita absent. 20 ಆಯ್ತು 21 22 23 24 25 25 Bhanupriya 26 27 27 28 29 30 30 31 32 33